Good afternoon, guys. Wanted to welcome you back to class this week. The first thing I want to do before we go over our warm-up question is go over our notes from section 1 today, chapter 4, section 1. You guys read through this yesterday to find the vocabulary terms. It all starts off with Newton's second law of motion. Newton's second law of motion says a net force acting on an object will cause the object to accelerate in the direction of the net force. So if I have this marker sitting here and I enact a net force by hitting it, the marker will accelerate in that direction of the net force. If a car is traveling along at a certain speed and you apply the brakes to the car, right, it'll accelerate in the direction of the net force. It's slowing it down. It'll be a negative acceleration. So that's Newton's second law of motion. It can also be written as an equation. F equals ma. Force equals mass times acceleration. Two other big concepts from this section. One is acceleration due to gravity. As long as we are on the Earth, all objects accelerate at 9.8 meters per second squared. Meaning, if I drop two objects, a heavy object and a lighter object, negating air resistance, they're both going to hit the ground at the same time. What we would have done had I been in school, we would have had a warm question about shooting a bullet and dropping a bullet. If you shoot a bullet out of a gun and drop a bullet at the exact same time, they will hit the ground at the exact same time. Now, granted, the bullet you drop will hit the ground right below you. The one you shot out may be a mile out there, but it will still hit the ground at the exact same time. The second concept is air resistance. Air resistance is determined by two factors, speed and surface area. Two examples of this. If you are driving down the road and you stick your hand out the window and you're driving 5 miles per hour, there's not much air resistance. There's not much force pushing back in your hand. But if you try to go down the road 55 miles an hour and do the same thing, your hand's going to very quickly get blown backwards because there's much greater air resistance there. The second one is surface area. Drive down the road and put your hand this way and then turn it up, and then put it this way and then turn it up. You'll see when you turn your hand up, there's much more air resistance being present there. We're going to get to that tomorrow. These kind of combine when we talk about terminal velocity. So we're going to wrap this section up tomorrow with terminal velocity. The last thing, though, before I give you your assignment for the day, is I want to make sure I go over the warm-up question with you. We had two questions here. The first one says, it takes a force of 300 newtons to accelerate an empty 1,000-kilogram car at 3 meters per second squared. If a 160-kilogram wrestler is inside the car, I'm not sure why it has to be a wrestler. It could just be any other person, but apparently the person being a wrestler is important to our book here. How much more force will be needed to produce the same acceleration? So let's write down our info. And this is why it's always important, guys, to write the info down. In this case, there's a lot of confusing information here. The first thing it tells us, a force of 3,000 newtons is needed to accelerate the car without the wrestler in there. You don't really need to know that. So that's why I just crossed that out. I wrote it down, but as we go through here, you realize that's unimportant information. That information does not deal with this problem. Second, the mass of the car is 1,000 kilograms. It accelerates at 3 meters per second squared. The mass of the wrestler was 160 kilograms. It's asking how much force it will take to accelerate the car with the wrestler in it. So we need to find the mass of the car plus the wrestler, which would be 1,160 kilograms. Our equation we're going to use for this is force equals mass times acceleration. The mass would be the combined mass of the wrestler and the car. The acceleration is 3 meters per second squared. 1,160 kilograms times 3 meters per second squared gives you 3,480 kilogram meters per second squared. That's starting to become a mouthful. You could always write kilogram meters per second squared. I will never mark that incorrect because as I've always told you, just draw a box around your units. You don't have to memorize them. But because that's getting to be a mouthful, a kilogram meter per second squared is equivalent to a Newton. We can also use the term Newton for that, right? If you have laws of gravity named after you, you're important enough to also have a unit of measurement named after you as well. So that's our first problem. Our second one we have a 63 kilogram skater pushing off a wall with a force of 300 newtons. What is the skater's acceleration? And this is similar to one of the velocity problems we did last week, where you use the equation kind of in reverse here. The key to that again is writing down information. The mass of the skater is 63 kilograms. The force is 300 newtons. So we're looking for acceleration. We don't have a formula for acceleration, but we have a formula that has acceleration in it, that if we have two of the other variables, we can solve for the third one. So let's use that F equals ma equation that we've been using. The force is 300 kilogram meters per second, or newtons, and I'll show you in a second why I use the term kilogram meters per second squared instead of newtons. The equals 63 kilograms times the acceleration. We need to isolate acceleration by itself. So let's divide both sides by 63 kilograms. And that's why when you cross the kilograms out, you're left with meters per second squared. So our acceleration is 4.76 meters per second squared. That would be your acceleration. All right. Your assignment for today, after we go over this, is to do the section review questions 1 through 3 on page 99. Attach those, turn those in to me. Tomorrow, we're going to go over those review questions. We're also going to talk a little bit about terminal velocity before we move on to section 2. As always, guys, if you have a question, please email me or jump onto my office hours. I'll be more than happy to help you out. Have a fantastic day, and I will talk to you guys tomorrow.